Hey everybody, this is Mr. Walsh, and we're back to our ionic compounds here. And we already talked about how these things are formed. So let's then now tackle how they're going to be named and how to make formulas. Okay. And so we kind of talked a little bit about this when we talked about how they're formed, the electrons moving around, transferring. Okay. But now we're really going to hone in on naming and writing formulas for these things. Okay. So, the way that we name these things, and we have to know the elements' names. Now, the periodic table that I gave you has the names of the elements on them. This isn't exactly it, but even this periodic table has the names of them on there. So you don't have to feel alone or lost because of that. Okay? And so, if we're going to name this, the way to do it is element root-eyed. Okay, so here we have Na, that's sodium. Okay, and then this is chlorine. So it's sodium. The root of chlorine is chlor, and then we add IDE to change it. Okay, so that we know that it's a compound. Otherwise, if we just do sodium chlorine, it just sounds like we're listing elements. Okay, so it's the name of the element, and then the root of the second element plus ide. So AlBr3. We don't have to worry about the fact that there's three of them. It's not a problem that we have. We're just going to name this aluminum bromide. Okay, aluminum and bromine. So we do aluminum bromide. This is lithium and nitrogen. So this is lithium nitride. Okay, so that's going to be the challenge for you, is knowing where the ide starts. Okay, so the root of nitrogen is nitro. Okay, it's not nitro, it's nitride. Okay, and then this is magnesium and phosphorus. So this is magnesium phosphide. Okay, so one of the things that I like to do is to make sure that for the nonmetals, you know exact, because it's always the metals are listed first and then the nonmetals. So for the nonmetals, here's what you have in terms of the ionic naming. So carbon is carbide, nitrogen we talked about turns into nitride, oxygen is oxide, fluorine is fluoride, phosphorus. A lot of people add an extra syllable there, but it's not. It's just phosphide. So just be careful. And then sulfur turns into sulfide, chlorine, chloride. Okay. Selenium is actually the one that changes the way it's pronounced, changes its pronunciation, and it goes from selenium to selenide. It's spelled the same. You know, it's Selenide. So it doesn't change any spelling in the root. It just changes the root pronunciation, so it's selenide. And then bromide for bromine, and iodine turns into iodide. It almost sounds like you have a cold. And then the other nonmetal, remember hydrogen, that turns into hydride. Okay, so element root-eyed. So we're going to name the two elements. That's magnesium and iodine. Magnesium, and then iodide. Iodine turns into iodide. Okay. Sodium and oxygen. So this is sodium oxide. Now, just so you know, and I make this mistake too, so it's not a huge deal, but just know that these are not proper names. Okay. They're not proper. So you don't have to capitalize them. They shouldn't be capitalized unless it's the first word of sentence. Okay. So it's not like, my name, David Walsh, gets capitalized. It's just regular words. Okay. So what about this? Alpha. Okay. This is aluminum and fluorine. So this is going to go to aluminum fluoride. Now, definitely spell fluorine correctly. Okay. Now, if you're going to try to make compounds, one of the things that I recommend is you use what we call the crisscross method. Okay, and you may have picked up on this in the previous video. If we know the charge on the elements, we can use that charge to figure out how many of them there are. We don't have to necessarily go into the Lewis symbol, okay? So Li and then O, like this, okay? We don't have to do this and then another Li, and it comes in here, okay? And we get Li2O, okay? We don't have to do that. If we know what charge these things are, look, Li forms a 1 plus charge, and oxygen forms a 2 minus charge. What we know is, what we can do is we can crisscross these charges, leave off the sign, and so that means we're going to need 2 Li's to cancel out the 1 oxygen that's there. Okay, the crisscross works. Okay, and so you'll hear me say this a lot in class. Like, I'll be like, everybody clap your hands. Right? And so we're going to crisscross. In order to do this, we need to have the charge. We need to know the charge of these things, and that's something we can get from the periodic table. Francium has 1 valence electron, so francium is a 1 plus charge. Oxygen has 6 valence electrons, so it's easier for this to gain 2 electrons. So oxygen will want to have a 2 minus charge. So if we're going to do this, we're going to crisscross, and this is going to be Fr2O, crisscross. So lithium nitride, Li is 1 valence electron, so Li gives a 1 plus charge. Nitride has 5 valence electrons, so this becomes a 3 minus charge. So we're going to crisscross. Let's see, make sure I do this right. 1 plus and N3 minus. So we're going to take crisscross, and this is going to be Li3N. Magnesium iodide, Mg, 2 valence electrons. So this becomes Mg2 plus, and iodine, 1, 2, 3, 4, 5, 6, 7. This needs 1, so this is going to become iodine 1 minus. So let crisscross, and we get Mgi2. So that is what you need to worry about for writing formulas. Okay, you may even want to break out the periodic table and write the charges on the main group. These all have 1 valence electron, so this is going to be a 1 plus. These have a 2 valence electrons, so that's going to be a 2 plus. All of these have 3 valence electrons, so this is going to be a 3 plus. Okay, now if we come over here, if we start and work our way in, helium, neon, argon, the noble gases don't have any charge, that's a 0. Fluorine has 7 valence electrons. The halogens have 7 valence electrons. So that means that it needs an extra electron to become like a noble gas. So that's going to add an extra electron. That's a 1 minus. Okay? And then oxygen is a 2 minus. Nitrogen, because it has 5 valence electrons. All of these in this family have 5 valence electrons. So this is going to be a 3 minus. And it's only the middle group that we have 4 plus or 4 minus based on the octet rule. And we're going to use those charges situationally, whether it's 4 plus or 4 minus. Okay, so there you have it. That is our way to name and write formulas that you're going to have to do. Have a great day, everybody.